Alright, welcome to week 10 of Gen Chem Lab. So today we're going to be doing the spreadsheet for IonExchange that we did last week. This is looking at Moodle for this week. Pre-lab assignment says that you need to complete the IonExchange pre-lab spreadsheet exercise. Don't worry about that. You don't need to do that. Complete the preliminary percent water spreadsheet assignment and upload the spreadsheet below. And so if you, hold on a second, this might be tricky. I'm going to make that small. So, whoa, that was too far. If you look down here, there's the upload link right there. And the directions are right here. It says design an Excel spreadsheet for experiment 9, the percent water in unknown crystals lab. So what I would do, and what I would like you to do, is simply open up an new Excel file, all right? And then look in your lab manual. On page 62 of your lab manual is this table that you copied into your lab notebook. And pretty much if you just put this data in almost this exact format into a spreadsheet, you're going to have to do all the typing and everything. That will be a very good start to your spreadsheet. So if you could have that done by Thursday, that would be outstanding, and then I can look at them and I can give you some feedback. This is the actual spreadsheet is not going to be due until after Thanksgiving, so it's no rush, but you do want to get started on it. So that is my best suggestion. You should just open up a new Excel file and copy all of this table basically by typing it in, and then put your data in. Everyone should have 2 columns worth of data, one from you, one from your lab partner. And again, the reason for that is just so that you have multiple trials, and if one of you messed up, hopefully the other one did okay, and you'll end up with a good percent water at the end. So that's the first thing that you need to do. And then the second thing that you need to do is, hold on. Okay, so going back to what we're doing this week. So today, what we're doing is discussing data analysis and reports for IonExchange and percent water labs. Complete any data collection for the percent water experiment. So most of you were done with the percent water experiment a couple weeks ago, so you're definitely not going to have to do that. We're going to be working on this spreadsheet for IonExchange, and I'll also show you the rubric for the IonExchange report that will be due next Thursday. All right, so let's do the spreadsheet. You want to have out your graphs that you printed off. You're going to want to have those out, okay, because you need to have the equivalence points. So this is a titration that I did, and these are all my equivalence points. So make sure you get that out. And then you also want to have open the IonExchange spreadsheet. It's not bigger. All right, so there's your IonExchange spreadsheet. So you're going to open it up. So put your name. We'll just say Dodo. We are section 12710. And massive green crystals. So you wrote this down in your notebooks. I know you did. It was somewhere between 0.155 and 0.165. So I'm just going to pick a number in between there. Say 0.160. The concentration of NaOH. You should have that written down in your notebook as well. I'm just going to make one up here. It's something close to 0.1. Okay, molar mass of potassium. Where can we find molar mass of potassium? That'll take you back to your first exam. By the way, I am making this screencast while my children are playing soccer in my basement, so if you hear lots of yelling and loud noises, that's why. Do you want to say hi, Michael?
Hi.
Okay, so to find the molar mass of potassium, you're just going to look at your periodic table, and it is 39.098. And so you're going to type that in right here. And you already have your units of grams per mole. For iron, do the same thing. Find it on your periodic table, 55.933 on mine. So I'm going to type that in here. Oops, I just forgot what it was. All right. So now we get to the calculations part. So you see this is the geometric row and this is the derivative row, which corresponds directly to the graphs that you printed off. This would be the geometric equivalence points, and these are the derivative equivalence points. If yours doesn't look this nice, it's okay. Try to use your partners. Maybe your partners looks better. And honestly, if neither of yours looks okay, it's okay to use this one. I don't want to see everyone having the same answers though, okay? So if you have a halfway decent one, please use that. Okay, so in the spreadsheet, first thing it's asking for, initial volume for my geometric and my V1, that's my first equivalence point. So I'm just going to look right at my graph, and I'm sure that you all wrote all these things down on your graph before you left lab. But I have 9.52 and I have 10.65, and so I took those and I found the average to be 10.09. So that's what I'm going to put right here for my V1, 10.09, and I want to say that I had 0.55 as my original volume, which I actually forgot to write down, so bad on me. Okay, here's a calculation. Remember, red boxes are calculations. They have to start with the equal sign. I'm just finding V1 minus V0. So V1 is cell D12 minus C12. Hit enter, all good. Moles of potassium. Now, if you look here, and I'm going to post this on Moodle just so that you have it. This explains what we're doing here. So in our green crystals, we had potassium and iron. The potassium knocked all of those hydrogen ions out of the ion exchange column in a 1-to-1 ratio because they both have a positive 1 charge. And so where the sodium hydroxide that from our burette that we were adding neutralizes the hydrogen that got kicked out, that is your amount of potassium, because moles of hydroxide will equal moles of hydrogen ion that were kicked out, which will equal the moles of potassium ion that replaced it in the ion exchange column. So all we're going to do is take our concentration of sodium hydroxide that you wrote down, and you're going to multiply it by the volume that we used to get to that first equivalence point. Now, in the past, when we did this with that last titration, we had milliliters on top and on bottom. This time we don't. We just have molarity and volume in milliliters. So you have to make sure that you put the 1,000 conversion factor in there. You have to divide your milliliters by 1,000 to get liters in order to get the right answer here. So moles of potassium is going to equal my concentration of sodium hydroxide. You want to put some dollar signs in front of that so that Excel will keep on going back to that same cell when you copy this formula. And then we're going to multiply it by our net volume. And then we just have to divide that by 1,000. And that will give you your moles of potassium. Okay, mass of potassium. Just going from moles to mass. All you're doing is using your molar mass up here. So equals my moles times my molar mass. And again, I'm going to put dollar signs in there so that I can just copy and paste this formula in the next row. My dog is also chewing on a bone. so you might hear that too. Okay, percent of potassium in sample. This is a weight percentage. Okay, so we have our mass of potassium, we have our mass of our sample. Actually, I'm gonna and so we're just going to get the mass percent. So equals my mass of potassium divided by my mass of my green crystals times 100, and that is my percentage of potassium in my sample. Okay, so that's all good. Equivalence point 2. Go back to looking at the graph that you printed out for your geometric equivalence point. For me, these were my 2 points here and here, and I averaged those and I got 18.87. So that's what I'm putting in here, 18.87. Red box, I have to hit an equal sign, V2 minus V1 moles of iron. Okay, so this calculation is a little more challenging, so let's look at this. So what happened in this titration is all of the sodium hydroxide that you were adding, it was all reacting with hydrogen ions up until this point. Once the hydrogen ions were gone, it started reacting with the iron, because we know that iron hydroxide, iron 3 hydroxide, is not soluble. So the hydroxide reacted with the iron, reacted with the iron, reacted with the iron. All of a sudden, all the iron was gone, and then you just had hydroxide left. And so it explains it down here in words. So as you keep adding OH past the first equivalence point, more and more of the iron plus 3 turns into FeOH3 until all of it reacted. So what we're going to do is find our moles of hydroxide first, just like we did previously. Oh no, of course we're not going to do that. Okay, hold on. So you find your moles of hydroxide, and then you just have to remember that the ratio of iron to hydroxide is 1 to 3. And so whatever you find for moles of hydroxide, you actually have to divide by 3 to get your moles of iron. So this equation here will be very similar to this, except that we're going to be dividing by 3. Okay? All right, so first I'm going to take my concentration of NaOH. I'm going to hit the dollar signs, and I'm going to multiply by my net volume, and I'm going to divide by 1,000. Now I think what I'm going to do is put this in parentheses so that this whole thing can then be divided by 3 to get moles of iron. To get mass of iron, you're just going to take your moles times the molar mass. Again, use dollar signs. And I'm hitting enter. And then to get my mass percent, I'm just taking my mass divided by mass of my crystals times 100, enter. Okay, so I'm about to run out of time on my little free screencast software. So down here, you're going to do the same thing. You're just going to be taking the points from here. So for my derivatives, I had 10.05 and 19.0. So I'm going to plug these in real quick, and then I'll show it again. Okay, so I plugged in my numbers, and guess what? You can just copy and paste all of these fantastic formulas from one row to the other once you have your blue squares filled in with your values. I am not paying attention to sig figs right now, so you need to think about that. I'm going to make another quick screencast to show you what you need to do for your lab report. So that should be it for your spreadsheet other than checking on sig figs.